alpha halogenation in aldehydes and ketones. An acetaldehyde, for example, we have 3 alpha hydrogens. When you take alkane, the halogenation is not fair reaction actually. Alkanes are very stable only under 2 conditions, either the UV light or the 250 degrees if you apply, alkanes undergo halogenation. But see here, you take the acetaldehyde is a liquid in fact. You take this liquid acetaldehyde and pass the gas chlorine. This gas is passed through the liquid, no catalyst, no heat, nothing. You will get all the halogens will get halogenated. Trichloroacetaldehyde is formed. The reaction is found to be so easy, it can be questioned why it is so easy. Means all these hydrogens are hyperconjugable. That's why the reaction is fair reaction. You get a trichloroethanol called commonly chloral. The formation of chloral is so easy in fact. Similar, the reaction can also be, has one particular observation. When chlorine you are passing, add 1 drop of NaOH, the reaction will become much more easy. Whereas 1 drop of acid you add, chlorine, in presence of chlorine you add the main reagent, but they make 1 drop of HCl you add, that is any acid if you add, the reaction will become slow down. Why the reaction is becoming slow means hyperconjugable hydrogens exist in the form of enols. If we show hyperconjugation, consequently what happens, hyperconjugation leads to give the enol formation, right. Enols are acidic in nature. So, when you add sodium hydroxide, the enols will become salt. That means the hyperconjugation is becoming more and more ready in presence of the basic medium. Whereas if you add acid, acid and acid common ion effect, so reverse will taking place. Hyperconjugation is suppressed by the acidic medium or increased by the basic medium. So, not much base if you add, it undergoes haloform reaction. You get trichloro this one, and this on adding the excess of halogen, if base is there and temperature is there, haloform is formed, CHCl3, and the corresponding salt is formed. This is called haloform reaction. That's why don't add much sodium hydroxide, just 1 drop of sodium hydroxide, 1 drop of HCl, the lot of difference will come. The observation will become very fast halogenation, very slow halogenation. This itself is a easy reaction on which this how this acid and the base is influencing means the carbonyl compounds are aldehydes specifically through hyperconjugation forms a enol. The enols are acidic because the enoxides can undergo resonance stabilization, proton is liable to give. So, this enoxides stabilization gives the enol to acidic. So, we have an acidic medium and you are adding the acid. So, common ion effect is there, this is acidic, this is acidic. So, therefore, common ion effect shift the compound into the keto. So, in acidic medium ketones dominate, in basic medium enols dominate, that is also in the tautomerism we have observed. So, that is what through enol means hyperconjugation is accelerated by the basic medium, that is why halogenation also will become faster reaction. Similar reaction if you take in the acids, it is a rare case however. In the acids what happens you just see. In the acids like propanoic acid or acetic acid, let us take. Acetic acid also has got a hyperconjugable hydrogen, 3 hydrogens are there. Add the chlorine gas into the acetic acid liquid, nothing happens it seems. The same hyperconjugation is there just like acetaldehyde structure up to this is common, isn't it? So, it is also hyperconjugable situation is there. Why not undergoing the reaction means here, as I said in the previous case also, the lone pair want to show the mesomeric effect. This is the lone pair want to show the plus M effect, sigma bonded electrons want to show this plus hyperconjugation. So, they are contradicting each other. Only available carbonyl group is 1, but both the side they want to show, I want to show, I want to show. So which is dominating means lone pair versus pi bond is always dominant, that is mesomeric effect or resonance effect. This is plus M effect. So always a M effect dominates over the hyperconjugation. This is plus mesomeric effect. So this mesomeric effect always dominates over the hyperconjugation because it is resonance. This is the no bond. The bond we have to cut and then use. Without cutting, the electrons are available. So therefore always using the minus is better over the lone pair, over the pi bond, over a charges, over a sigma bond. Sigma bond utilization, though it is hyperconjugation, is no doubt it is powerful, the phenomena. But utilization, if criteria of the utilization comes, it is the utilization of sigma bond. Sigma bond itself is a very strong bond. So breaking the bond and taking electrons are coming into the force, the action taking place, anyhow it is difficult when compared with the mesomeric effect. That's why the mesomeric effect is dominating and the hyperconjugation is suppressed. That's why there is no reaction. However, the reaction made possible by a combination of three different scientists by applying a small change here. A chlorine in presence of phosphorus, this is called Hell-Wohlhard-Jelinski reaction. Hell-Wohlhard-Jelinski reaction, HVZ reaction. All three scientists somehow tried to get the alpha chlorinated acetic acid. Why they are so much interested in the alpha chlorination means alpha chloroacids on treatment with ammonia or subsequently you will get alpha amino acids. Those are the protein building blocks. So therefore we are interested in the alpha amino acids. So this alpha halo acids preparation has become very easy through this particular small catalyst. Maybe halogen phosphorus will give some PCl3, PCl5 types of compounds in equilibrium, maybe reactive chlorine may be available, that makes the reaction. In spite of less reactivity, that is less possibility of the hyperconjugation, the catalyst phosphorus makes this reaction possible, and the reaction really it is very popular reaction known as HVZ reaction. This is nothing but a alpha halogenation of the carboxylic acid made easy in presence of chlorine, that is with chlorine in presence of phosphorus. Here we are applying the hyperconjugation concept and observing all these particular features.